Hello and good morning. Just making sure everybody's with us. Right now we have 312 guests online, so welcome. So we welcome you during this very difficult time. For accepted students, it's a time of congratulations, however, for what you've accomplished, and a quiet looking ahead beyond our current crisis to what you can accomplish in the coming years. We will need every one of you. So I'm Chuck Stewart. I'm a professor and head of the computer science department. I've been here 32 years, and I have to say I love this place. I'm proud of our faculty. I'm continually amazed by the community of bright, incredibly hardworking, and technically fearless students. I hope you join us. So this talk is a hybrid of the presentation made by the Dean of Science, but it is a specialization to computer science. After the main presentation, there will be two things. One, I will do an online question and answer, and we will be joined by two current Rensselaer students. In addition, we will have a separate session where you can sign up, register to talk one-on-one with a current student. We're using an application written by one of our sophomores, and it's been tested out heavily over the last week. And there are about 40 current students who will be waiting to talk to you. They'll be available from 12 to 2:30 Eastern Time today. And there will also be opportunity to sign up for session later on if you can't meet now or if you want to meet later. It's very important, of course, to meet one-on-one. We wish you could do it on campus, but these are indeed extraordinary times. Okay, so this is the welcome, and congratulations for being invited to join the class at Rensselaer 2024. So there's two very exciting things about your graduation year. First of all, this will be the 200th anniversary of the first graduation from RPI students. We're the oldest technological university in the country, and we're quite proud of this. So if you can see in this picture on the lower left, there's the Dean of the School of Science, Kurt Brenneman, Associate Dean Sabella Dali, who's a professor of computer science and also a winner of the Trustees Outstanding Teaching Awards and Counseling Awards. And this is Lee Ligon, the other Associate Dean of School of Science. Now, the second event is a solar eclipse on just 6 weeks or so before your graduation. And as you can see, the center of it goes across Lake Erie, Lake Ontario, and up through the Adirondacks. The edge of the total eclipse is just north and west of campus, and campus is right about here. So we will be fairly complete in our eclipse. So exciting things for 2024. We have a community of very, very strong students. If you look at some statistics here, the average SAT scores, 70% in the top 10% of the class, 35% identify as female. In computer science, that number is 25%, and that is almost doubled over the last 6 or so years. So we're proud of that, even though we have more work to do in that area. And we'll talk about that a little bit later. Computer science students, you should all congratulate yourself. I don't have the statistics in front of me, but in fact, every year you are the strongest group of students among any major at Rensselaer. Very, very impressive. So you're really coming to join a community of scholars, a community of very strong students. We also have an amazing faculty. Now, these 8 individuals are all professors of computer science. So starting with the upper left, that's Professor Barb Cutler, who teaches, who works on graphics and visualization, but she's also leading a student-run or a student-written effort to develop an online course submission, grading, community discussion board, and we will talk about this project called Submittee later on. Carlos Varela is a full professor. He is known for his work in distributed computing, and he also is working on distributing computation among planes as they're flying. so that they can gather information that can be used to control the plane more effectively. George Slota here is an expert on graphs. Graphs are a fundamental construct in computer science, but his graphs are on the size of billions of nodes. Professor Larong Cha is an expert on social networks, or social choice and computation, and AI, and the relationship between AI and economics. Stacy Patterson is an expert on distributed computation and the Internet of Things, which is when all the different devices, the sensors in your cars, are connected to perform computations and control behaviors. Professor Yangshi Gao is an expert on networks, and in particular, the resilience of networks, which of course is a crucial question right now. Professor Anna Milanova is an expert on program analysis and security, and a lot of her recent work is detecting when code has been tampered with. It's very amazing stuff. And finally, we have our leader of our effort in large-scale machine learning, and that is Professor Alex Gittins. So those are 8 of just 26 faculty in computer science, and we hope by the time you arrive, we will be over 30. So computer science is part of the larger school of science, which has a wide range of activities and majors and minors, and you can see some of them listed, including very interesting stuff on astrobiology and biology in high stress environments. And we will be talking later in the presentation, or I will be talking about information technology and web science, and of course the major focus will be on computer science. So it's very important to think about what happens after graduation. Where do our alumni go? So this is a snapshot for the School of Science. About half start in employment right after graduation. In fact, that number is quite a bit higher in computer science. A smaller percentage go to graduate school. Many of them actually stay for master's degrees at RPI, and we will talk about that a little bit later. Students are involved in research and co-ops and projects. And you can see on the right here a wide range of just some of the companies students join for co-ops, internships, full-time jobs, and also some of the university students go for graduate school. Sometimes in one-on-one discussions, parents ask me, where do our students go? And I ask, where do you want to go? Because our students go everywhere. Here's the cool thing. You saw that $79,000 average starting salary. The average starting salary in computer science last year was $96,000. Very important to emphasize that this is about a return on investment. And some of our alumni even go to outer space. So this is Reed Wiseman, who flew on the shuttle several years ago and actually spoke with faculty and students on campus while he was in space. This is a summary of the School of Science degree program. The major courses, usually about, well, actually, I want to back up for just a second. I remembered something I wanted to say here. There's a second thing I want to emphasize about this return on investment, and that is why people come here, companies come here to recruit. They come here to recruit because of technical skills, but also technical leadership, and very much because the technical fearlessness of Rensselaer alumni. Our students are among the first that companies come after. On a daily and weekly basis, I get phone calls and emails asking, how can I hire your students? And that is really the Rensselaer difference. We have excellent students, a community of wonderful students, and breed a culture of fearlessness in approaching technical problems. Okay, in your degree program, this is a summary for the School of Science, so I won't spend too much time on it, but there's a distribution of major courses specific to your major: science, humanities, and social science, and culminating experiences, and a communication requirement. I'll spend more time talking about these when we get to the specifics of computer science. Housed in the computer science, but really institute-wide, is the Information Technology and Web Sciences program. It is ranked #1 in the country by College Choice, and it's really it's less deep, less technical than computer science. It includes some computer science courses and then a range of other courses in management, in web technologies, and other topic areas, so that it has a broader base, but it's less technically focused than computer science. There's a core in IT, and that core includes a core introduction, some web courses, Computer Science 1 and data structures, and a few other more cultural and sociological studies. That's the core of ITWS. And then there's engineering, science, humanities, and Haas concentrations. These concentrations are 8 courses. Many students who major in ITWS concentrate in computer science and actually pick up computer science as a dual major. So that's one option, and we will talk much more about dual majors soon. We also focus on a variety of new methods in how to teach science and technology. This starts out with the Bridge Scholars Program for students who want more of a slow ramp on calculus and physics. So that's a mixture of on-campus and mostly off-campus activities throughout the summer before starting. We have several strong mentoring programs. The I Persist Mentor, this logo you see to the right, is for basically a tutoring program, a small group tutoring program led by an undergraduate in calculus, chemistry, and physics. Computer science has what we call programming mentors. These are students who help in labs, office hours, and online discussions. Starting as students are hired as early as second semester, freshman year, those students who have done very well. It's a competitive program. We have 125 a semester, and students either paid or get credit, and they're the ones who are there one-on-one to help you understand a problem, to review what the solutions you're trying to come up with, to find bugs, to fix things, to explain concepts. It's very important, and we have strong backing from the Dean of Science and from the Provost and the President for our program. The last thing I want to mention here is Submiti. I mentioned it a little bit before. Submiti is written by our own students, led by Professor Barb Cutler, who was the first professor I highlighted a few slides ago. It originally started out as a way for students to submit their programs, have them checked online, run against test cases. The next step is it provides a way for teaching assistants to get access to your code so they can review it, critique it, and grade it for you. So you get both the objective tests and the grade and critique from the TA, giving the TA more time to focus on that critique. But Submiti has grown into much more than that. There's a grading distribution server. There are ways at places where we post assignments, we post lecture notes, and we post recorded lectures. And most importantly now, there's chat rooms for online discussion boards. And in particular, during this time of completely online education, the Submiti team has implemented a tool where students come into the office hours, virtual office hours, enter a queue, and then get picked up for one-on-one discussions by TAs and programming mentors, so that you can share your screen, look at code, ask questions, and have a one-on-one discussion, and really try to mimic some of the effort that we do online, or individually, we're trying to do it online as well. So big things are our mentoring program, and our use of Submiti really made a very relatively easy transition to online education. There are a lot more than that in our curriculum and being a computer science major. First thing I want to emphasize is dual majors. So a dual major is where you satisfy the degree requirements for two majors. And you receive a degree that says you have both, you're a major in, for example, computer science and ITWS, or computer science and mathematics, or computer science and computer and systems engineering. So you have fulfilled the requirements of both majors. That doesn't mean, for example, if one major requires 4 math courses and the other requires 5, that you have to take 9. It just means that along your courses, you've satisfied both degree requirements. About 30 to 35% of the computer science majors have a dual major. The biggest ones are the ones I mentioned: math, ITWS, computer and systems engineering, but you're going to hear from students today who are dual majoring in psychology as well. Students can minor in other areas. Next thing I want to mention is this coterminal, which is essentially you can get a master's degree and your bachelor's degree in 5 years. Important thing is financial aid continues for the 5th year. So we have a strong master's, coterminal master's in computer science. Some students think, well, I won't just get a dual major, I'll get 2 degrees, where you actually have to not only get the requirements of both degrees, but 30 additional credits. And we actually strongly advise against that. If you have the room and time to get the additional coursework, we strongly recommend that you do the coterminal instead. So again, lots of computer science majors, dual major. Some of them pick up minors. You'll hear about that later from one of our students. And if you have extra time and extra interest, you can get a bachelor's and master's in 5 years. And students who transfer in or are able to take more courses sometimes do it in 4 or 4.5. Students get heavily involved in research, both during the academic year and summer. Co-ops and internships are very important, both during the arch and afterwards, and I'll talk about that. And then there's a very strong interest in starting companies. We have startups in all sorts of areas, including cybersecurity. So our students are constantly thinking about this. So a little bit about the Arch. It is a focused summer usually after your sophomore year, so you're a rising junior. You get more interactive experience with faculty and a chance to hang in the area. The Capital District is beautiful in the summertime. And then during your junior year, you have 1 semester that's called away, where you might do an internship, or even more interesting, you could do a co-op, say, in the spring and summer of your junior year, and you really get a 6-month experience. And there are many companies who are very interested in this because they want more than just the 3 months of a co-op. Other option is you could do, say, a co-op in the fall and then another co-op in the summer. There's study abroad, internship, research, and service as well, but most of our students do internships and co-ops. Another comment about the internship, you will often see 2 different companies. You will do it in the fall, say, at one company, and then in the summer afterwards at another, and you get to experience 2 different corporate cultures. Very useful. The research at Rensselaer is heavily focused on global challenges. The most obvious one for computer science is AI and machine learning. And of course, that is important both for the core technology, but even more so for the ways it's being applied. Very interested in types of molecules and materials, heavily use of machine learning and AI in this, and there's a lot of interest among the faculty. Power, renewable energy, healthy planet, again, strong interest at Rensselaer. One thing you might hear about is the Rensselaer Amos Supercomputer. It's an artificial intelligence computer. To get a little geeky, 252 units. Each unit has 2 powerful processors and 6 GPUs. If you don't know what this means or really don't have a feel for it now, that's just fine. We don't expect that. Fortunately, undergraduates have access to do this through research and through courses. I have 6 students currently working on it, 4 of whom were either undergraduates or co-terminals. And this is currently moving toward heavy use in COVID-19 vaccine research. We've opened it up for projects throughout the country. So we're very proud of this. Very easy to get access to it, and students are using it all the time. You heard our student speaker talk about Lake George. The Lake George is one of our global challenges. We're focused on fresh water and maintaining the integrity of freshwater systems. And so there's a study program at Lake George. It is called the Jefferson Project because apparently Thomas Jefferson visited once and called it the most beautiful lake in the world. If you get a chance to visit, it's about 45 or 50 miles north of campus. It is stunningly gorgeous. It's got Adirondack Mountains all around it, and it's a long, beautiful, clean strip of lake, heavily instrumented by Rensselaer scientists and engineers, and a lot of data analytics goes on. And it's an effort combined with the local community, with IBM, and with Rensselaer. This one is not so much computer science, but it's super cool. Professor Karen Rogers is the leader of the Rensselaer Astrobiology Research Program. She's an expert on extreme environments. She's gone to all sorts of cool places and just finished an expedition to some collecting samples from thermal vents deep under the ocean. So now we're going to focus on the computer science degree program. And I'll slow down a little bit here. So first of all, there are 8 named courses, 6 of them in your first 2 years. And after taking them, those 6 courses, you are very well prepared for internships. The kind of things, technical questions you're asked for internships, you're very well prepared. After those 6, there's 2 more in the senior year. 1 is offered during the Arch, and that's operating systems. Beyond those 8 courses, there's 4 capstone or option courses, and you have to choose them from among 4 areas or choose them from research courses. So the 4 areas are AI and data, theory, computing systems, and computer vision, graphics, and robotics. So there are lots of flexibility in courses, and some courses count in multiple areas. For example, I teach the computer vision class, and that counts in both AI and data, and in computer vision, graphics, and machine learning, or computer vision and graphics. As a computer science, you have to take 7 math courses or 7 science courses, 4 of which are math, 3 of them are science. Then there's the usual 6 humanities courses. There's room for at least 6 free electives, and that's often enough to pick up a dual major. There's a communication requirement, one of which is in the humanities, arts, and social science, and one of which is in computer science. And we have about 6 or 7 courses, I don't know the exact number, that can fulfill this requirement. And that leaves you with 128 credits needed for graduation. So during that, if you think about it, that is 8 16-credit semesters or 8 4-course semesters. So there's no need to take extra courses. And if you don't have any AP credit, you don't have to take anything to get started. You just take 8 4-credit semesters, and you're done. So computer science is the biggest major on campus, and of course the best major with the smartest students. Just ask me if I'm biased. The answer is, of course, yes. But we very strongly encourage you to get involved in the computer science community. Find your peer group, find that group of students you want to hang out with, you want to help each other with your homework and understanding concepts. You really need to find your crew. And so here I'm going to talk about 5 different organizations that are centered in the department that students are heavily involved with. The first is the Rensselaer Center for Open Source. And it was started about 12 years ago by an alum who had made money in a mapping company. So it is a semester by semester projects. You can propose your own project. They're all open source. You form teams of usually 3 to 6 students. Some teams have as much as 8 to 12. Some of these are just exploring new ideas. Some of them are joining some of the worldwide open source efforts. Some of them are continued projects that have been persisting for 4, 5, or 6 years. Submiti, of course, is one of them. Yax is yet another course scheduling software, and that's what almost all Rensselaer students use to figure out their courses for the semester. There's bus scheduling software. We've had support from Google, and we've had students start to contribute to our projects from all over the world. Typically, 150 students a semester are involved in ARCOS. So the second one I want to talk about is the Association for Computing Machinery Women's Organization, ACMW. You're going to hear a little bit about it from Herta, one of the students, but it is a combination of formal and informal mentoring with faculty, trips to the Grace Hopper Celebration of Women in Computing. We've sent about 25 students a year. Tech talks from companies willing to hire. And most recently, the leaders of ACMW have formed an informal mentoring program where current students are connected one-on-one with existing students or with new students. And this is part of the reason our percentage of women in computer science has more than doubled over the last 6 or so years, and the overall number has grown by a factor of 4. We are also heavily well known throughout the world for our security club, RPISec. And this is a group that was started, it's almost entirely student run. It was started through the suggestion of one of our professors, Bulent Jenner, and some of his graduate students, but the students then took off and they run it themselves. They place in the top 3 in many worldwide capture the flag competitions. And if you're not familiar with those are basically self-contained offensive and defensive security competitions where you try to break into other computers and you try to prevent other teams from breaking into yours. It's heavily focused on building skills in this all-important area of cybersecurity. They've won some fun prizes like this basketball, but they've also won prizes like checks for $10,000 that they use to support their efforts. They've been invited to competitions all over the world, Taiwan, China, Central Europe, and then, of course, all over the United States and Canada. They're also known for this course, Modern Binary Exploitation, that is open source courseware that's used all over the country and the world. Even companies are using it. And the RPISec has a very strong alumni network, and there are startups in downtown Troy formed by ARCOS alums. The next organization is HackRPI, which is the Hackathon Club. Again, student started and student run. We've had first-year students become leaders of HackRPI. Last November, they had over 400 participants in the hackathon event. Our next event is scheduled for mid-October or mid-November. And they're looking at both online and offline versions. They're planning for global challenges, including analysis of pandemic data. And this is great for recruiting and internships. We gather students from all over the Northeast and some from all over the country. A lot of the students, though, are Rensselaer students. And what's interesting is we get companies who will either come to both the career fair and the hackathon, or companies who will only come to the hackathon and then become sponsors. So very exciting, and students can join the hackathon and participate in their first semester here, and as I said, become leaders. Very, very important. Coding in Community is a service organization started by Melina Gonzalez, who is graduating this year. But she has passed on the leadership of this to underclassmen. Teaching basics of programming to underserved population, that's the goal. The goal is not necessarily to get them to be computer scientists and software engineers, but to really develop skills in programming and understanding computation. They're mentors in the New York State Science and Technology program, and they also hold weekly events for Troy middle and high school students who are just off those schools are just off the eastern edge of campus. The last one I want to talk about is the Honor Society, Epsilon Pi Epsilon. You are admitted through a combination of academic accomplishment following the Intro to Algorithms class, which is scheduled for the 4th semester, but many take it in the 3rd. They have tech talks, programming competitions. They often set up faculty for competitions with each other. For example, choose which choice of editors is best, or say computer science trivia. And with that, the challenge is always, can the students beat the faculty? Won't tell you who wins, just the older folks, really. A lot of strong alumni networking like there is with all clubs, and they have their own meeting space in the Amos Eaton building. And I just want to point out, in that Amos Eaton building on the 1st floor, there's both the Epsilon Pi Epsilon meeting space, as well as a much larger community space for students to get together during office hours or for group team efforts. And our advising center for computer science is there as well. So we want you to come join us to expand our impact. We have excellent faculty. We're focused on global challenges. We have outstanding students. Really must stress that enough. What you're coming here to do is join with the faculty, but really join in a community of brilliant, hardworking, technically fearless students. We have state-of-the-art facilities, strategic partnerships. For example, with AI right now, they're providing us with funding to build up faculty in AI and machine learning. So please come join us and do great things.